A linear function is a function that can be written in the format y equal to mx plus b, or if we want to write this using function notation, f of x equal to mx plus b, where with the linear function here, m and b, m is the slope of the function, which we'll talk about more later on of what that is, and b is the y-intercept, meaning that's where the graph is crossing the y-axis, the vertical axis. So now, in this next problem here, we want to determine whether the following functions that we have are linear functions, and if they are, what is m and what is b? So the first one, we have y equal to 2x minus 5. And with this one, yes, it is a linear function. We can write it so that it is in our y equals mx plus b format. The only change we would have to do in order to specifically have it be plus b would be to rewrite this where it was 2x plus a negative 5. And we don't necessarily need to have to rewrite it like this, but this just shows a little more clearly that yes, it is a linear function. So then what is m? What is b? Well, m is what we're multiplying the x by. So m is 2. And then b, that's what we're adding on at the end, which is our negative 5. The next one, we have f of t equal to 7 minus 1 over 3t. And the first thing that I want to clear up here is we're using a different letter. We're using t. That's okay. We can use other variables, other letters instead of x, as long as we're just consistent in what it is. So we have f of t equal to 7 minus 1 over 3t. And with this one, we also have this one being switched. So we could rewrite this as being negative 1 over 3t plus 7. And now it's a little bit more clearly in the mx plus b format. So we can say, yes, this is a linear function. And now our m for this one is what we're multiplying t by, which is negative 1 over 3. And then our b is the positive 7. The next function, we have g of t equal to 2 over 5t plus 4. And the issue with this one here is we have 2 over 5t. And one thing that I want to make a little note of, that 2 over 5t, this is not the same thing as 2 over 5 times t. If you notice on the left side, t is in the denominator of that fraction, while on the right side of that, not inequality there, not equality, t is being multiplied it. So it would have to look like this, the 2 over 5 times t, in order for it to be a linear function, and not what we had in our equation, 2 over 5t. So this part here makes this not linear. We cannot rewrite 2 over 5t so that it is in our m, a number times t format that we need for a linear function. And then our last one, we have k of s equal to 12s. So instead of x, we're using the letter s. Instead of f, we have the letter k for the name of the function. That's okay, we can use different letters. But now, can we write this so it's in the mx plus b format? Or in this case, we'd have ms plus b. And we actually can. If you notice, we don't have anything that we're adding to this. So what we can technically do to show this is add 0, and that will give it to us in our mx plus b. where now our m is going to be 12 and our b is just 0. That here would tell us our y-intercept b is crossing at 0, 0, the origin of our graph. Next, what we're going to do is graph a linear function. So starting off for this with our table here, we're going to do what we did in 5.1 to graph a function to fill out the table and get our ordered pairs. And then we'll go over a little bit of what we can do with graphing specifically linear functions. So we have the line L equal to 2 over 3t minus 4. And I want to put in different values of t into the function. So the first one, we want to put in -6. So that's going to give us 2 over 3 times -6 minus 4. And that should then give you -8. So our ordered pair is going to be -6, -8. The next one, we want to put in -3 for t. So 2 over 3 times -3 minus 4. And that gives us -6. So our ordered pair is going to be -3, -6. The next one, we want to put in 0 for t. So 2 over 3 times 0 minus 4. That gives us -4. So we have 0, -4. Then we want to put in 3 for t. So 2 over 3 times 3 minus 4. And that gives us -2. So we have 3, -2. And then lastly, we want to put in 6. So 2 over 3 times 6 minus 4. And that gives us 0. So we have 6, 0. So now on our graph, we want to plot these points that we have. So our axes, our input was t, so that goes on the horizontal axis, and our output was L, so that goes on the vertical axis. And now we want to plot these points that we have. Our first one is -6, -8. So I'm going to go left 6 from the origin and down 8 to get the first point. And then we have -3, -6. So we're going to be -3 and then down 6. And then we have 0, -4. So we're not going to move at all on the x-axis, but then we're going to go down 4. And then we have 3, -2. And then lastly 6, 0. So that's on our t-axis for this. And now we can connect all of these points together, and you should see that they are starting to look like a straight line. And that's what it should be because our function is linear. Whenever we graph a linear function, it's always a straight line. Okay. So now a little bit about this function and how we can graph linear functions without having to plot a whole lot of points. What we technically only need is 2 points for the linear function. So our two main things from a linear function is the slope and the y-intercept. Our slope in this was m equal to whatever we're multiplying t by, which is 2 over 3. And the nice thing about slope is we can think of it as being rise over run. So the rise tells us how much up or down the y-axis we're going on if it's positive or negative. And then our run is how far along the right we're moving on the x-axis. And then we also have our y-intercept b, where we're subtracting 4 in our equation, so it's the negative 4. And that means that's where we're crossing the y-axis, or in this case we're calling it the l-axis. So now we can take a look at this and we can see that that point 0, negative 4, we can get that just by looking at b in our equation. And then we have our slope being 2 over 3. So that means we would go up 2 and then over to the right 3 to get the second point on our graph, which we had gotten there by one of our calculations of evaluating different values for t. And just with that, we could have graphed this equation with those 2 points, and we would get the same exact line.